Good afternoon, everyone, and welcome to our webinar on best practices for magazine analytics. And this is the first part of our webinar. The second part of this webinar will be on Wednesday, December 13th, and it is available on our Eventbrite page. So let us get started. Okay. So a little bit about ourselves. We are an analytics consulting firm. We are based out of New Jersey. We use machine learning, data science to help organizations make better decisions. And we serve a lot of companies in the magazine space. We work with nonprofits. We work with some financial service organizations as well. Okay. This is a list of some of the magazines we have worked with currently or have worked with in the past. So let us get on with what we want to talk about. Some of best practices around using data science and machine learning for magazine analytics. So the first, and the way we have set this up, there are going to be like some key points which we have observed over the years, best practices we will highlight. Today we are going to highlight 5 such points, and the next week we are going to highlight some more. So the first point is that do not waste incentives. So what do we mean? So incentives are like free issues, often wrapped in a poly bag and sent to the potential subscriber, or it might be some very special pricing that are often offered to increase subscriptions. So, however, there are people who would subscribe without these incentives, and the publisher should develop a method to identify those who would subscribe anyway and not offer them that incentive, because that's a drain on resources. And a technique to do it would be uplift model. uh, this will allow incentives to be offered to only those who will buy without it, and will lead to substantial savings. In terms of uplift modeling, uh, one way to look at it is that the universe can of potential subscribers can be divided into um, buy if they don't receive the offer, buy if they do receive the offer. And the group we are trying to really impact are the uh, persuadables we have in this box here, which is basically they will not buy if they do not receive the offer, but they will buy if they do receive the offer. And you want to avoid um, the sure things, because they will buy without giving the offers, without receiving the offer. And then you definitely do not want to target the do not disturbs, because then you will get a negative result, and the loss causes you are just wasting money. So it is at least what should be done, and what uplift model does is allows you to differentiate between the sure things and the persuadables. And that's something which is very useful to do. It can lead to significant improvement in the financials without impacting the outcome of the campaign. So very important to do. Uh, We will at some time, if for those who are interested in the getting into the technical aspects of how we do it, we are uh, you know mm, creating a schedule of webinars for 2024, and definitely this will be one of the webinars uh, that we will include in our schedule. um, so do keep checking our Eventbrite page for that. Okay. A second point is identify hidden biases. So promotion samples almost always have pre-selection biases. So these pre-selection biases occur when certain behavioral or demographic group is dropped. For example, uh, men are excluded from women's magazine. Now, this could lead to like the men and women is a very obvious one, but there could be a lot of other things which are going on. Now, what happens now is the model learns from the data it is presented from it. So when you present, say, you're building a model for women's magazines, and you only have women in there, you've excluded all the men from your promotion, rightly so. What happens then is that in the data there are only women. So the model learns from what is presented to it. So all responders are women, all um, uh, non-responders are women. So gender does not get picked up as an important predictor of who is going to buy this women's magazine. And at the end, when you are applying this magazine to a general universe, uh, you will get very, very weird results where you are targeting a whole bunch of men. So to remedy this, there are two things you can do. Mm, Either learn about the filters properly and what were applied, which might be possible if it's an internal situation. A lot of times you are doing list rentals where you're modeling for an external client, and then some of this information might be lost. But if you apply the pre-selection filters to your universe, you will take care of this. So for example, in the women's title, which is an easy way, intuitive example, often it's more complex than that, the pre-selection. But over here, if you also filter your universe to take all men out, your model will again start working. Now, the other thing you have to also keep in, or rather another way to solve this would be to generally create non-randomized subsamples which can correct the bias for the modeling sample. And um, we have a white paper on this on our website, and we will probably have another schedule webinar on bias correction as well. So keep tuned to our Eventbrite page. Okay. Another important thing I want to bring to this discussion is that we should change tools to adjust to audience characteristics. And a key thing to ask here is the target audience diverse or homogeneous? If they are so models targeting lapsed subscribers of our magazines have a relatively more homogeneous audience. Again, it not may not always be true, but it is, that's why I use the term relatively more. But it is relatively more homogeneous audience compared to models trying to cross-sell magazines to a diverse pool of subscribers of multiple titles. So definitely, if again going back to the women's title, if the magazine is only there for women, so and It might be women with a certain lifestyle or interest, for example, health. So your audience is a little bit predefined and less heterogeneous than if you are trying to cross sell to a pool of different magazine subscribers that include people who read sports title, people who read car magazines, people who read food magazines, and as well as women's title, and you're trying to promote any title to them. So that's a lot more heterogeneous pool compared to your original pool for, say, a single title. So a model which depends on a single equation uh, picks up the major predictors and works well for a homogeneous audience. For years we have been doing logistic regression, and that's kind of an example. That's not the only technique, but uh, it is an example of a technique which does very well with an homogeneous audience. There is a standard equation, and that equation picks up the key predictors, and you get a solid, robust model. However, when, like the second example I said, where the pool is very diverse, the logistic regression still works, but the uh, population, but there are a lot of sub dynamics at play. Like I said in that example, there could be, uh, people interested in cars, people interested in health, people interested in food, all in your pool, and that's makes it a lot more diverse. And the dynamics of identifying who is likely to buy from there might be different. There are different demographics, different age, different income, all of that, and you can still build a single model, but a lot of it is lost. And that is where machine learning type technique, for example, XGBoost, which builds multiple models with different subset of predictors and sample of the population, might be more effective. And just to illustrate this point a little bit more, like this shows what a traditional model does. Like you have all these pocket of uh, um, this pocket of potential subscribers, and a traditional model is trying to minimize, uh, kind of build a model which kind of minimizes the is sum of square of errors, and is going to create some kind of an equation which captures the main trends. But as you see in this illustration, like for example, this small pocket out here, uh, this is most likely lost to to this technique, because there might be small dynamics of subscribers and so on, but they're not influential enough to make it to the main model, or maybe even contradictory to the dynamics of the main model, and they are lost. So there is a lot of potential subscriptions that are lost in a diverse audience when you do a technique like this. So instead, the machine learning algorithm will take subsamples of the population and subsamples of the predictors and so on, and create more localized models, which all will be blended together to get the final results. So there is a greater chance of building um, a model which is more representative and captures a greater audience. So this is an example, like this is a best practice. It helps significantly. Okay. The next point I want to make is, let the data identify itself. What I mean by that is, develop data-driven segmentation. And this is related to the earlier slide. Uh, basically populations, your audiences are diverse. So once the sample is built out and you have all the predictors and you have all the people you want to model about, it might be a good exercise to understand just based on the predictors, what are the natural dynamics in the data. And techniques like k-means, k-nearest neighbors, canonical distribution analysis can be leveraged for this exercise. Um, mm, this might not be the final segments due to certain operational, business related or budgetary constraints. You might be restricted to number of models you can build, all of that, because the way marketing works or the way your infrastructure works or the simple cost of doing something that elaborate. But it is good to do this anyway, because you get an understanding of what your data is, what your underlying dynamics is, and you can use that to get better results. So again, we are going to have a webinar in 2024 which talks about uh, the segmentation approach. It's going to be fairly detailed, but just to give you an idea how you would go about it, you would prepare data to prepare data for unsupervised clustering. You would need to do some standardization to the data, create certain class variables, create cluster classifications. Then one of the things we like to do is generally just create principal components. And what principal component is that you create basically, if you have 10 predictors, you create 10 new predictors, which are some combination of these predictors. And these new predictors have the characteristic that they are not correlated to each other. So when you develop principal components and you plot against principal components, you are able to see like if like each principal component explains a certain variance of the data. So if you take the top two and plot them against each other, or take the top three and plot them against each other, and you see the data breaking into pockets, that gives you an idea that, okay, the data has clusters. And then you can at that point proceed to, one thing we like to do a lot is canonical discriminant analysis. And the output you see below is using the scaled and standardized data to do canonical discriminant analysis, where the data beautifully breaks up into 4 segments. And um, and this is kind of an overview of best practices, so we're not going to go into the details here, but this is do look out for our webinar where we go into all this in greater details. Uh, Another thing you would want to do is perform k-means clustering. It's a popular approach. And using k-means clustering, you can get, okay, these are the optimal number of clusters in the data, and you get characteristics of each of the clusters. And in k-means clustering, the way you do it is you you tell the algorithm, okay, I want 3 clusters, I want 5 clusters, so on. And then there is also a k nearest neighbors approach, which looks at basically records which are similar to a particular record and kind of clubs them together and creates, and then it tries to find optimal number of clusters by itself. It's non-parametric, and it is useful to do that. Why am I suggesting doing all these different approaches? It gives you a good understanding of your data. You look at it different ways, and you get greater confidence that the clusters you have built, the segments you have built, are reasonable, statistically robust, and will serve you well when you do the modeling exercise. Okay. And then the next point I want to make, and this is the final point I think I'm going to make today, is do not put all the eggs in one basket. What do I mean by that? Balance out the predictors. So if the model, at the end will have a certain set of predictors, and this is true even more for traditional models like logistic regression. If the model depends too much on one or two predictors, it is more likely to be susceptible to sampling errors uh, and changes in the market or popular dynamics, or population dynamics, or to even changes in some data, some any error. When you are dependent, you are not diversified, your model is not diversified and focuses too much on one or two factors, it is exposing your model to risks of failure. And due to this model can become unstable over time and lose and have low shelf life. Often a solution is to segment the data based on the dominating predictor. So if, say, you're trying very hard, and but the model, one field is just suing the model and controlling the model, a lot of times an approach could be, okay, let us break this predictor into one or two segments, and base, and then develop submodels. Another technique which works very well is weighting observations differently. They can help you reduce the contribution of different predictors. And uh, machine learning techniques like XGBoost are less likely to be susceptible to this problem. And the upfront segmentation I talked about in the just before this point is might also reduce this problem significantly. So I hope this gives you some points. This is based on, we, as I stated at the beginning of the presentation, we do a lot of work in the magazine publishing industry, and it's just we thought it's a good idea to share some of what we have learned with the general uh, mm, group and practitioners, so that we can all learn from each other and develop better models. uh, Here is a listing of some of the offerings we offer in the magazine space. And finally, please do keep looking at our Eventbrite page, or our LinkedIn page and our website, because we keep coming up with new webinars on different areas, including magazine analytics. And please remember, if you like this and would like to get the next set of best practices we have, do tune in for the second part of this talk next week. It is there on our Eventbrite page. Okay, thank you so much, and have a wonderful afternoon.